This is example 2 from our substitution and elimination for nonlinear systems lab. We have the following system: 2x squared plus 3y squared is equal to 20 and x squared plus 4y squared is equal to 5. This problem is primed for elimination, the method of it. And so what I'm going to do is use elimination. I look at our variables and I figure out that I want to eliminate x squared because it's by far the easiest to multiply and get rid of. So I'm going to do so. I need to multiply this x squared by -2 so that when I add them, these 2x squared and -2x squared will cancel out. So I'm going to multiply this entire bottom equation by -2. So we have 2x squared plus 3y squared equals 20. And on the bottom, distributing this -2 across, we have -2x squared minus 8y squared is equal to -10. So we're going to add this entire bottom fraction to our first one. So 2x squared plus -2x squared, well, this will just cancel out to 0. We have 3y squared plus -8y squared, that's -5y squared. And 20 minus 10 is 10. So now we notice that we only have one variable left, y, so we're going to solve for y. So dividing by -5 on both sides, we have y squared is equal to -2. Square rooting on both sides, get rid of this square. We have y is equal to positive negative square root of -2. Remember, when we square root to get rid of a square, we need to actually add the positive negative sign in there, because if we plug this back into this equation, this could be negative or positive to get this -2. And we can rewrite this as y is equal to positive negative square root of 2 times I, because I is equal to the square root of -1, and if you remember our rules for logarithms, the square root of -2 is equal to the square root of 2 times -1, which is equal to the square root of 2 times the square root of -1, and then since I is -1, it's equal to this. So, well, notice we have two solutions for our y. We have a positive and negative square root of 2 times I. So we need to take this y and plug it into either one of these equations to find our x, but we need to choose which one it is first. So, first off, I'm going to choose y is equal to positive, for now, to I. So I chose that, and we're going to sub into the bottom equation from our system here. X squared plus 4y squared is equal to 5. So, getting into it, we have x squared plus 4 times square root of 2i squared is equal to 5, which is x squared plus 4. Now, if you remember what our square root of 2 and I is, before we simplified it into that form, it was the square root of -2, and if you square a square root, then it's just going to be this -2 here. So this is just -2 after it's squared like that, is equal to 5. So you have x squared minus 8 is equal to 5, which is x squared is equal to positive 13. And then square rooting on the both sides to get rid of the square, we have x is equal to positive negative square root of 13. So we notice that from this alone, we have two possible solutions where this is positive. We have, for positive square root of 2i, we have the positive 13, square root of 13, and square root of 2i. And we also have negative square root of 13 and square root of 2i. So there's two solutions here. But remember, we also have a whole nother y to deal with where this is negative. So we're going to do that one now. So we chose our y is equal to our negative square root of 2i, because it was positive and negative, if you don't remember. And then we're going to sub into the same exact equation we did before. X squared plus 4y squared is equal to 5. So this is x squared plus 4 times negative square root of 2 times I is equal to 5. So x squared plus 4, and this negative will go away after it's squared, and so it just simply becomes, again, -2 is equal to 5. So we have x squared minus 8 is equal to 5, which is x squared is equal to 13, which is x is equal to positive minus square root of 13. So we notice that we got the same exact x for this one. So when y is negative square root of 2 times I, we have two solutions. So we have a positive square root of 13 and a negative square root of 2i. And we have a negative square root of 13 and a negative square root of 2i. So we actually have four solutions for our system. And they are, from before, when our y is positive, we had our square root of 13, positive square root of 2i. We had our negative square root of 13 and our positive square root of 2i. When our y was negative, we had positive square root of 13 and negative square root of 2i. And we had a negative square root of 13 and a negative square root of 2i. So we have four solutions. We'll notice, however, that they are all imaginary. And if you graphed our original equations, this 2x squared plus 3y squared is equal to 20 and our x squared plus 4y is equal to 5, you'll notice that those are circles and that our answer in reality do not actually touch each other. So in reality they don't actually ever intercept. However, we found that in imaginary numbers they do.